equation. Let me just start from the beginning. Now, the first question we have here. Oh, all right, guys. So we are going to look at practical activity 6.2, which is acid-base titration. Now, acid-base titration has to do with a reaction between an acid and a base to form salt and water. It's a neutralization reaction. Now, the first question we have here for the activity 6.2 is that we should write the formula of sulfuric acid. Sulfuric acid is H2SO4. That is the formula. The next one is write the balanced equation to represent the neutralization reaction. The equation has H2SO4 reacting with sodium hydroxide because the reaction for this activity was between sulfuric acid and sodium hydroxide to give us sodium sulfate and water. Now, the balanced equation, you have 2 here, all right, for sodium hydroxide. Then water, you also have 2 molecules of water. H2SO4 is aqueous, sodium hydroxide is aqueous, sodium sulfate is aqueous, and water is liquid. And that is that for that one. Now, the next one is this table. We have the initial burette reading, final burette reading. Then this is your rough. This is your first titer, this is your initial titer. Now your initial burette reading for this particular person was, for this first titration, was 15.40. Final burette reading is 31.20. To get the volume of sodium hydroxide used, you subtract final from initial, which is 31.2 minus 15.40, and that gave us 15.80. Same thing for the second titer. 47.7 minus 31.20 will give us 16.50. This one is rough. You don't usually consider this one when you are finding the average volume used. So you are now going to write average volume of sodium hydroxide used, my dear student, would be this volume for the first titer here plus this one divided by 2, which will be 15, which will be here 15.80 plus 16.50 all divided by 2. And this will give us 32.30 divided by 2, which gave us 16.15 ml. All right? So this is the average volume of sodium hydroxide used, 16.15 ml. Is that okay? Exactly. Now, the next one is record the volume of acid used. The volume of acid used was given to you as 25.0 milliliter. Your volume may be different, but this is basically what I was given that you were told to use. Then record the molarity of the base used. The molarity of the base used for some persons was 0.2 molar, while for some other persons was 2.0 molar. But for this practical, I am going to use 0.2 molar. Depending on the one that you were given in your department. Some department we are giving 2 molar, so we are giving 0.2 molar. Now the next thing is calculate the molarity of H2SO4 solution. Is that okay? How do we calculate the molarity of H2SO4 solution? You have the balanced equation. The balanced equation is H2SO4, my dear student, plus 2 molecules of sodium hydroxide. I want this one to be here, because, right, plus 2 molecules of sodium hydroxide plus, this will give us what? Sodium sulfate plus a molecule, 2 molecules of water. This is liquid, this is aqueous, this is aqueous, this is aqueous. All right? Now, having done this, the general equation for titration, my dear student, for what you know in your secondary school, is CaVa all over CbVb is equals to what? Na over Nd. Is that okay? What is our Ca? The concentration of acid is unknown. That's what you are looking for. What is our Va? The volume of H2SO4 given, which is 25.0 ml. All right? Then the next one is the CB. The concentration of the base given for this practical is 0.2 molar. And then the last one is VB. The volume of base is your titer value volume, which is this one you calculated here. Is your volume of base. For this case, it's 16.15 mil, depending on your own. So your VB will be different from what I have here, depending on the values you have. All right, so we have 16.15 mil. Then Na is, if you look at what we have here, the acid has a mole ratio of 1, the base has a mole ratio of what? 2. So Na is equals to 1, Nb is equals to 2. We are talking about what we have here. This one is 1, this one is how many? 2. So mole ratio Na is 1, Nb is 2. So Ca is what we are calculating. Va is 25.0, Cb is 0.2, Vb is 16.15, equals to Na is 1, Nb is 2. Is that okay? Now at the end of the day, this cross multiply, this will multiply this will give us Ca times 25 times 2 is equals to 1 times 0.2 times 16.15. This multiplied by this will give us what? 50 Ca is equals to 0.2 times 16.15. Let me reconfirm. So we have 0.2 times 16.15, which gives us 3.23. Then divide both sides by 50. This cancel this, my dear student. Our Ca is now 3.23 divided by 50. So divide by 50 will give us 0.0646. So Ca will be equals to 0.065 molar. So that is our Ca for this particular question. Just follow the procedure here and do your own calculation. Is that understood? Exactly. Now the next one is HNO3 and H2SO4 have the same molarity. Why did H2SO4 require about twice the volume of sodium hydroxide solution for the titration? This is the answer. Here, just copy for this particular one. I will explain in detail when we meet in class. Is that okay? But whatever we have here is very, very correct. So you should just copy this, pause it, and copy it. Then this one also, pause it, copy it. It's very correct. All right? I'm going to explain when we meet in class. It's very correct also. So just pause, copy. We don't have time. This one also is well explained. Is that okay? So also pause this one and copy. And then this is the last one. Also pause it and copy. All right? Explain the effect of, okay? Also pause this one and copy. Is that understood? Exactly. Now, using the molarity of H2SO4 solution obtained from your titration, calculate the molarity of 26.0 ml of ethanol solution that requires 32.50 ml of H2SO4 to reach end point. Now, this is a very simple question too. What is the equation of reaction for this? We have ethanol reacting with H2SO4. Although this reaction is not really an acid-base reaction based on the knowledge of chemistry. However, we should just do it the way it is because ethanol is more acidic than even be called a base. And acid cannot react in neutralization reaction. However, we are still going to do it anyway, the way it is. So plus H2SO4, this will give us CH3, and then here will be what? SO4 plus what? H2O. Is that okay? Now, from this equation, our Na is 1, our Nb is 2. All right? Now, our Ca, concentration of acid, is what we just calculated for, which in this case was what? 0.065 molar. Whatever you get here becomes your Ca. Is that okay? So we have 0.065 molar. All right. Then Va, the volume of acid, they gave you that calculate the molarity that requires 32.50. So volume of acid is 32.50 mil. The volume of base, this case was given 26.0 mil because the base now in this case is what? Ethanol. So we have 26.0 mil. All right? Exactly. So what other thing do we need? Cb, concentration of base, is what we are looking for. So we use the formula. What is that formula again, my dear student? The formula is CaVa all over CbVb is equal to what? Na over Nb. Now, our Ca for this particular one is what? Ca is 0.065, Va is 32.50, Cb is 26.0 mil. I mean, Cb is what we are looking for. So you write Cb times 26.0 mil is equals to Na is 1, Nb is 2. I mean, is 1 over 1. Nb is also 1, not 2. Sorry about that. Nb is 1 because the mole ratio is 1:1. All right? So when you cross multiply this, my dear students, what's that going to give to us? This multiply this will give us 26 what? Cb is equal to, use this one to multiply here. We're going to give us 0.065 times 32.50. All right? So we have 32.5 times 0.065, which give us 26 Cb is 2.1125. So divide by 26. Our Cb, my dear student, will be this divided by 26, which gave us 0.081 molar. So our Cb is 0.081 molar. Is that okay? So that is the answer to that question. Now name the titrate and the titrant. The titrant is the reagent with known concentration. Now, which of them do you know the concentration that was given exactly? It was sodium hydroxide. So the titrant for this experiment, my dear student, is sodium hydroxide. Why the titrate is the one you are looking for something inside, which is the analyte. And the titrate for this experiment is H2SO4. And most of you don't know what to do, just copy. Exactly. So that is that. Now, we have another one here that says, write the balance equation between sodium carbonate and hydrogen chloride. Now, if you have a reaction between sodium carbonate and hydrogen chloride, what would be the balance equation? So, and also indicates the mole ratio for the acid and base pair. So we have 2HCl aqueous plus sodium carbonate aqueous. My dear student, this will give us 2 sodium chloride aqueous plus H2O liquid plus what? CO2 gas. This will be the equation of reaction. Now the mole ratio of acid to base is 2 mole ratio 1. You can write it. Acid to base is 2:1 because the acid here has a mole ratio of 2. The base has a mole ratio of invisible 1 that is not seen. All right. The next one is sodium hydroxide and hydrochloric acid. So we have hydrochloric acid aqueous reacting with sodium hydroxide, aqueous. This will give us sodium chloride, aqueous, plus water, liquid. The mole ratio for this one is 1:1 of acid to base. And then the last one is H2SO4 and sodium bicarbonate. All right? What do you think that one will be? So we have H2SO4, aqueous, sodium bicarb, aqueous, to give us sodium sulfate plus H2O plus what? CO2. This is the balanced equation for this particular one. Now the mole ratio is 1 mole:1 mole. Is that okay? So that is basically that for this one here. If you count, oxygen here is how many? 4. Plus this one 7. Okay, it's complete. So this is the mole ratio is 1:1. And I think that is everything for this particular practical. We'll see in the next one. Bye-bye.